Hello and welcome back. We are in section 3.4, and we're going to be solving a system of linear equations with three variables. So what we have done thus far has been equations with two variables, like this, and two equations, like this, right? So two equations, two variables we solve for x and y, right? That's what we've done previously. What we're going to introduce in this chapter is a 3 by 3 system, meaning we are going to look at three variables with three equations. And I'm just looking at random numbers here. So recognize the biggest difference here is we have a whole nother variable that we have to solve for. It's not just x and y, it's x, y, and z now that we have to solve for. So that's the goal, right? And it's the same process, but it is a few more steps, right? It is a few more things that we have to unpack. So the general steps, the goal is to write what was a 3 by 3 system, right, with three variables. That's my three systems, right? That's my equal sign, right? To rewrite this as a 2 by 2 system. That's the first goal, right? To make something that has three variables and three equations, have two variables and two equations, okay? Then we do what we've done before. This is section 3.2 over again, okay? We're solving the 2 by 2 system. This is not new. And then we substitute the values from that step into one of the three variable equations, okay? So that's the general rule. The first thing is to make a 2 by 2 system, and then we're going to solve that 2 by 2 the same way that we've done. A couple other quick tips, because this is there's lots of calculations. So we want to make sure that since you're doing lots of calculations, I want to make sure that you go slow, right? Do not rush this. Make sure, because you have lots of calculations to do, you want to go slow and double check everything, because there's so many opportunities to make a mistake simply by making an error in addition, subtraction, multiplication, division, that you just got to be careful, okay? So let's go ahead and do an example. Here it is, right? Here's my 3 by 3 system. I have x, y, and z, and I have three different equations. And I'm going to call this equation 1, equation 2, and equation 3. Right? Just so I can have some labels to talk about them. What I need to do is choose one variable to eliminate. And I'm going to do, what I'm going to do with that is I'm going to eliminate that variable, and I'm going to eliminate it twice. All right. So I want to look through these, and I want to decide which one of these is the most easy to eliminate. And we're using that same method that we did before, right? By making things the same number and opposite. So x's don't look too bad, right? Y's don't look too bad because I've got a single y there, so that might be easy. Z's are looking kind of a bit more annoying because I've got a 3 and a 5. They don't share a common factor. 5 and a 4, they don't share a common factor. I don't want to do z, right? Z doesn't have common factors. I want to do the y's, I think. X's would be certainly good as well, but I think I'm going to go with the y's. So we're going to eliminate y. And what I'm going to do is choose two equations. And I'm going to eliminate the y in those two equations. So I'm going to go with equation 1 and equation 3. So equation 1 is 4x plus 2y plus 3z equals 1. And equation 3 is 6x minus y plus 4z equals -1. Again, I'm labeling these so that I can work with them. This is equation 1 and 3, and we're going to eliminate the y. So if this is 2, what does this need to be eliminated? -2. So how do I make this thing negative 2? I'm going to take this bottom equation and I'm going to multiply everything by 2. So my top equation is 4x plus 2y plus 3z equals 1. My bottom equation is now 12x minus 2y. I'm going to erase that little mark so we don't get things confused here. Minus 2y, back to my pen, sorry. Okay, minus 2y plus 8z equals negative 2. Notice that by doing that, I can eliminate the y's. So I end up with 16x plus 11z equals negative 1. Notice that this still has two variables in it, and I can't eliminate it. So I'm going to call this equation 4. Okay? We're going to use it a little bit later. I'm labeling this one equation 4. So what I'm going to do now is go back to my original set, and I want to create another equation with x's and z's. So I used 1 and 3 to create this one. I'm going to use 2 and 3 to create another one. And I could use 1 and 2 if I wanted to, but I think eliminating the y in 2 and 3 would be easier. So equation 2 is 2x, and I'm going to maybe we'll put the EQ in front of that so we know that this is just the label. Okay, 2x minus 3y plus 5z equals negative 14. And this one is 6x minus y plus 4z equals negative 1. And I need to eliminate the y. So this down here needs to be a positive 3, which means I multiply the bottom by negative 3. And my top equation doesn't change. My bottom equation becomes negative 18x plus 3y minus 12z equals positive 3. So the y's eliminate, and this becomes negative 16x 5 minus 12 minus 7z equals negative 11. And notice, and now I have another equation with x's and z's, and I'm going to call this equation 5. Whew, we're partway there. Notice that I have two equations with x's and z's. I have created a 2 by 2 system that we can now solve. In fact, this one ended up really nice. Look, 16 and negative 16. When I add these together, those eliminate. And this is a 4z equals negative 12, which means that the z value is negative 3. So notice that by creating these two equations, by eliminating y, I then created a 2 by 2 system, which I can solve. I can take this number and plug it in up here, like we did before. Negative 16x minus 7 times negative 3 equals negative 11, which makes negative 16x plus 21 equals negative 11. Subtracting 21 from both sides gets me negative 16x equals negative 32. Therefore, the x value is 2. So notice that I now have 2 of these solutions, right? Now I need to take both of these numbers and go way back to the beginning and plug them in up here in order to find the final solution. So that is going to look like, and I'm going to do that up here, 4 times 2 plus 2y plus 3 times negative 3 equals 1. This is 8 plus 2y minus 9 equals 1, which is 2y minus 1 equals 1. And solving this equation gives me y equals 1. I have all 3 of my numbers, 2, 1, negative 3, and that's my final solution, 2, 1, negative 3. All right, there's a lot to unpack on this, right? And it's going to take some practice. This one takes some practice. The method is very similar to what we've done, but you need to practice it, okay? So there's one practice problem for you to do in your Canvas, and then I've just got that. We're going to do that problem in one more video coming up next. So go give that one a try. If you get stuck, let's move to the next one, and we'll work on it together, okay? Because this one, like I said, this one takes some practice to get this process down, okay? So go give it a try. We'll see you in the next video.